So the theory exam coming up, I guess, in almost 3 weeks, about 3 weeks. You're going to be tested on chapters 18, 19, and 20. Chapter 18 is over the endocrine system, 19 is over blood, 20 is over the heart. And then next time we'll have 21, which is over blood vessels. But so we'll be going over the content of chapters 18 through 20 here. Now, for chapter 18, 18 is on the endocrine system, and most of what you need to know from that chapter is on this table. Okay, so hopefully you all got that. Does everybody have it? Mm-hmm. Did you all print the table off?
I didn't know it.
Yeah, if you go under, I think the last announcement I posted, I have a link to course documents, and I tell you to make sure you get this table. The table is called Endocrine Glands and Hormones, I think. But yeah, so make sure you get that. And what you'll see on the table are, first, before I even get into that, let's first define the endocrine system. What do you all know about the endocrine system? Hormones. Pretty good.
Glands.
Tissue. Okay. Glands, tissue. So the first thing that comes to my mind are hormones and glands. Okay. So the endocrine system is made up of what organs? The endocrine glands, right? So the endocrine glands are listed on the table on the left side. So these are the organs of the endocrine system. And then you'll see at the bottom other hormone-producing structures that are not considered organs of the endocrine system because they're part of other systems, like the heart is part of the circulatory system primarily, but it does secrete hormones, so it has endocrine function. The liver has many functions, the kidneys. So these are just some of the organs that we have that also produce hormones. Okay, so the main thing about the endocrine system is that you know what the organs of the system are, right? And they are the endocrine glands. Okay, so you all are going to learn all of those. And also, what does this system do primarily? Secrete hormones. Okay, so the endocrine system's job is to secrete hormones, which are basically just messengers. Another very amazing part of the human body. So these hormones are secreted from the endocrine glands primarily to maintain homeostasis. For example, name a hormone that you all know about.
Acetylcholine. Or, no, that's like
estrogen, testosterone. Any others?
Yes. What's the one for?
Oxytocin.
Yes.
Any others? What about thyroid hormone?
Thyroid.
What about what regulates blood glucose? Insulin.
I said the thing. That's acetylcholine.
So insulin, yes. And I like to use insulin as the first example of how this system works. So the endocrine system's main job is to maintain homeostasis. And what we learned about homeostasis before, even in 201 and 103, is that homeostasis is necessary to maintain balance. Without balance, we can't survive.
Yeah.
So the body has to, whoever designed the body, had to put in place some way to detect when things go wrong and a way to correct it when it does go wrong. Okay, so the endocrine system plays a big role in that. So what the endocrine system does, those glands know exactly when to secrete hormones. Those hormones are going to have some action to counteract some other action that has happened in the body. So for example, if we look at insulin, find insulin on your table. So you have the pancreas. The pancreas is an organ that has both endocrine function, and exocrine gland function. And we'll get into the exocrine gland function when we get to the digestive system. But the pancreas secretes insulin, and when it does, what effect does insulin have on the body?
Blood glucose level.
So insulin, when it's secreted, will lower blood glucose levels by storing excess carbs. So what does that mean? So what that means is when your blood sugar rises, which it does whenever you eat something, right? We know that blood sugar is not supposed to go above a certain level or below a certain level. So it's the job of the pancreas to regulate the glucose level that's in the blood. So if it goes too high, the pancreas has to know when that is and secrete the hormone insulin to bring the glucose level back down. Okay? The pancreas can tell also when the blood glucose level goes too low. And when it goes too low, the pancreas secretes glucagon, another hormone. And what does glucagon do?
Breaks down the glucose stored in the liver.
Increase blood glucose levels. Okay? So you kind of see how the endocrine system works. So if your blood glucose level is high, would you expect for the pancreas to secrete glucagon? Why not? So if it's high, glucagon will make it what? Go even higher. Okay? So somehow the body has to keep up with all this. So it has to be able to detect when blood glucose level is high and low and make sure it makes the correct hormone and not send out the incorrect hormone. And as we'll see, most of the time if a person has some disease, it's because their homeostatic mechanism, the normal homeostasis mechanism, is not working somewhere. Okay, with hypertension, with diabetes, the mechanism that is in place is not working. So just about every disease that we have, that's going to be the cause, the root cause. Somewhere homeostasis has failed. Okay? So the pancreas, insulin and glucagon. So we know the hormones, the glands that produce them, and that's kind of what you all need to start off memorizing first. And then after a couple looking at it a couple days, start to test yourself on those functions and make sure you know them. Okay, so what I'm going to tell you all is first learn the names of the glands and be able to tell which hormones come from that gland. Okay? To me, the best way to study this is using note cards. If you put pituitary gland, anterior pituitary on one side, and on the opposite side you put the list of hormones, you just make yourself learn it. Okay? I know a lot of students, I've seen a lot of students who say they read, and then do poorly on the test. But at some point, you have to start reading and testing yourself. Okay? If you're not making yourself remember without looking at it, then you're not learning anything. So I would say by Sunday, you all should be able to at least know half of the glands and test yourself, keep testing yourself every day, several times a day. Make yourself remember what those 6 hormones are. Okay? Think y'all can do that?
Mm-hmm.
So by the end of the weekend, I would say half of the glands you all should know the hormones. So the posterior pituitary, the hardest one is anterior pituitary because there's 6. Posterior pituitary only has 2. Pineal gland 1, thymus 1, thyroid. And I didn't put all of them up here, but most of them are. So the first one is the hardest, I would say. Okay, so you have a long list there. It ends eventually. But I know there are a lot of them. And then, so once you get that down, then you have something else to do. So that's your first stack of cards, the ones with the glands on one side, the hormone on the other. Then once you get that one done, now you go to the hormones, put one hormone on one side of the card, and the effect of that hormone on the other side of the card. Okay? But what I hope to do is help you so you won't have to memorize it. You can just look at most of the words and tell what they do. For example, TSH, thyroid stimulating hormone, the name tells you what it does. It stimulates the thyroid gland. Okay, growth hormone promotes tissue growth. Prolactin, that LACT, milk synthesis, okay? So most of them, I would say, kind of give you a hint. The name
So like
of the hormone gives you a hint.
until we like pregnant.
Right, exactly.
The hormone on one side of the card that the effector on the other.
No, the hormone, so the second set, you have the hormone on one side of the card, the effect of that hormone on the other side. And the only ones you have to do that for are the ones in red. Okay, so you don't have to know the effects of the FSH and LH right now. Hopefully I'll get to that in the later in the semester. Okay, and normally what I'll do on the test is I'll have a matching section where you have to match the hormone with the gland and also match the hormone with the effect.
So don't worry about the target organ.
Just the ones in red. And speaking of target organ, okay, so you all told me the endocrine system is made up of endocrine glands. What do those glands do? Secrete hormones. And where do hormones go once they're secreted? To the target organ. What is that?
The one
What
that
is
has
the
a
target
receptor for it, the organ that has a receptor for it.
Okay. So the
Is that right?
so the hormones are secreted directly into the bloodstream. And then, so that's first. Know that first. So whenever a hormone is secreted, it goes directly into the bloodstream. Okay? But it has a destination. Even though if I put anything in your bloodstream, if I inject you with Sprite, that Sprite is going to go where? Throughout the body. So every part of your body will have access to that Sprite. So the same thing, anything in your blood is going to every part of your body. So what do we mean by target organs? So it's in the blood. Let's just take one. So prolactin. So let's take prolactin for a second. So what does it say prolactin does? Produces and secretes milk and testosterone secretion. So where does prolactin come from? Yeah, where is it made and produced and secreted? Where does it come from? What makes it?
The anterior pituitary.
Prolactin is made by the pituitary gland. Where's your pituitary gland? Right, so you all know where it is.
Yes.
But it has an effect on what?
It has an effect on
So it goes into the bloodstream, right? But what does this mean?
It binds to the receptors in the mammary gland.
So it says the target organs are mammary glands, but prolactin goes to my big toe too. But my big toe ignores it.
Because it don't.
So the mammary glands, very good. So the mammary glands have receptors that react to prolactin. So all of these hormones have specific targets. In order for a target to respond to it, the target has to have a what? Receptor. Okay? So when I ask you where does the hormone go, it's not to the target organ. That's just what reacts to it. It goes into the bloodstream. It goes into the bloodstream, right? And as it circulates through the blood, whatever cells or tissues have receptors, those tissues will respond to it. Okay? Isn't that amazing? Who put all that together? Who knew where to put the right receptors? You know? Think
some
about it.
special means. Not a man.
Whatever. Whatever, but it is. It still amazes me how this
Yes, it is.
the engineering and all. Okay. So now let me kind of help you all with the names. And one of the main ones I'll ask you about outside of matching are you probably have in your study hints to know how blood glucose levels are regulated, something like that.
I think it's number 13.
Number what?
13.
13. Read it.
14, maybe.
What does it say? Read it. I can't hear.
Understand how insulin lowers blood glucose levels and understand how glycogen increases blood glucose levels.
Okay. I thought it had something like know how the body regulates blood glucose levels. But that's fine. Yes.
We can write that down.
Yeah. And you all should be able to explain that to me in a couple of ways.
No.
Easily. So how does the body regulate blood glucose level? So we know it has to stay in a range. You don't have to know what the top and bottom are, but just know if it goes too low, it can be fatal, right? So if our blood sugar drops too low, and that sometimes happens with people who are on insulin. They may take too much, and their insulin drops very low, and they have to what? Hurry up and eat something sweet or drink something, some juice or something, to get their blood sugar back up. So the immediate effect of low sugar is more detrimental to the immediate effect of high. So it's better to have a high sugar temporarily than a low blood sugar.
I have a question. Did you see that movie this weekend, Steel Magnolia?
I saw that years and years ago.
The
You know
new
what
one.
she, what the new
Oh,
one
it's a
she-
new one?
Yeah,
But Klingon too fast.
Get out of here.
it's real good. You're gonna cry.
All right.
But the girl, like, when her blood level dropped, she just went into, like, shock.
Mm-hmm.
And then, like, once they gave her the juice, whatever, then she came around.
They don't really be in shock, but they will hit you.
Well, yeah, she got me, well, yeah, because she was just like,
But think about it. Why is that happening?
yeah. Mhm.
If your blood sugar is low, what's not happening that should be happening? So
To make
remember,
ATP.
cells need oxygen and glucose to make ATP. So the brain cells instantly will start acting up. So people may start acting weird, and that's because they're not getting the adequate glucose to the brain. And so there must be some serious mechanism to control blood glucose levels. And so what that is the pancreas knows when to secrete insulin and glucagon. So let me ask you all this, because I may ask you on the test. So how many of you all had breakfast or didn't have breakfast? Let me ask that one. Haven't had anything to eat since last night sometime. Well, you're good. So those of you with your hands up, is that why you? Yeah, you need some energy, girl. Okay, so those of you who have not had anything to eat, which one do you think your pancreas is secreting now? Exactly. So if you haven't eaten in several hours, your blood sugar is trying to drop. But glucagon is not going to allow it to drop to dangerous levels. What is glucagon going to do? For those of us, I haven't eaten anything either. So if I check my blood, I would have obviously more glucagon circulating than insulin. Okay? And so what is the glucagon doing for me right now?
Breaking down the store.
So it's increasing my blood glucose level, but how? And that's what the question says.
I break it down hard.
By breaking down stored carbs. And what are those? Anybody remember which stored carbs? What are they called? Those stored carbs, and where are they? Well, look what glucagon targets. What's the target organ?
Liver.
The liver.
Liver stores the carbohydrates.
So remember, the liver keeps a storage of carbs, but what type of carb? Come on, y'all. We just talked about it in the sympathetic and parasympathetic. Because sympathetic does the same thing to the liver. Stimulates. So If you have a stored carb,
Start.
you know it's a polysaccharide then, right? Glucose is a monosaccharide. If you stick all those glucoses together, it makes a. Did you say it? I heard it somewhere over this side. Glycogen. Good. So stores it in the form of glycogen. You all need to remember that. Miss Ellison, congratulations.
Yay.
Even though you didn't sign the roll.
That's what it releases. Isn't that what the pancreas releases?
The pancreas is releasing glucagon.
Glucagon, not glycogen.
Right. Glucagon is a hormone. Glycogen is a polysaccharide, which is the storage form of glucose. Okay, you all need to know that. Okay? That's one of those questions I might ask you if I see you in the hall. What is the storage form of glucose? So when the blood has too much glucose, what is it stored as? Glycogen. 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 Polysaccharide. Made from many monomers of glucose. Okay? Starch is also made from many monomers of glucose, but animals store their excess glucose as glycogen. Plants store their excess glucose as what? Starch. Yeah, so starch is the same thing, but in plants. All right. So, insulin. So when you've eaten this morning, so those of you who did have a couple of Krispy Kremes, your insulin level was increased because the pancreas started releasing insulin to do one job and one job only, to lower blood glucose levels. But how does it do it? So again, all we're talking about is the amount of blood glucose in the blood cannot be too high. So somehow the insulin has to get that glucose out of the blood. So it's sending the glucose someplace else. Okay? Where is it sending it? So first of all, look at the target organ. So most tissue. So insulin, it doesn't eat the glucose. What it does is it tells the cells of our body, which are what need the glucose, right? So the cells of our body are what need glucose to make ATP. So all insulin does is tells the cells to open channels so glucose can come in to the cell. Does that make sense? Mm-hmm. So it's okay if you have too much glucose in the cell, because all it's going to do is use it to what? Make ATP.
Are all these action potential? Is all of this still action potential?
We're off the nervous system. So now we're in the endocrine system.
So
you're talking about the adrenal medulla?
mm-hmm.
That one, so we have, we'll get to that, but no. So the endocrine system and nervous system work similarly. The difference is, remember the nervous system, you had neurons releasing neurotransmitters and having an effect on another neuron or what? Smooth muscle, cardiac muscle, glands. Okay? So it's kind of the same mechanism in a sense, because you're sending a chemical to bind to a receptor eventually, like the sympathetic division sends norepinephrine to the heart and tells the heart what to do. Here, the glands are just secreting the hormone, not directly across from a muscle or a gland, but into the bloodstream, so it can have an effect on many other tissues of the body that are not muscles and glands necessarily. Okay? So it's kind of the same concept, but not neurons, so we can't call it the nervous system. Okay? So did y'all get that? So how does insulin work? So insulin lowers blood glucose levels, but you need to know how. By storing excess carbs. How? So the insulin, you can't think of insulin as a sponge, right? So by storing excess carbs could mean insulin is just storing the carbs itself, but insulin is just a chemical.
It stores the carbs on the tissues within the body.
Or through the bloodstream.
So the insulin, like I said, it binds to the cells of the body, right? All my cells of my body need glucose. So all it's doing is telling the cells of the body to go ahead and absorb the glucose and take it out of the blood. Okay, so it goes into the body cells. Y'all with me? Mm-hmm. Okay, 'cause y'all looking kind of like I don't get it. I want to make sure you all get it. Okay, so you just think of it as insulin is telling this body cells to open their door and let glucose in. So now glucose is not where. So if the glucose goes into the cells, it's no longer in the what? Blood. That's all we care about. Okay, and any excess is stored in the cells of the liver to be used at a later time. Okay, so that is how, that's just one example of how the endocrine system works to maintain homeostasis. You should also see a question in there that asks, how does the body maintain blood calcium levels? And blood calcium levels, y'all see that one? Is similar. And for you all, I would make sure I compare insulin and glucagon to two other hormones. The wrong way. The calcitonin and PTH. So just like insulin and glucagon regulates blood glucose levels, calcitonin and PTH regulate blood calcium levels. So blood calcium levels have to be maintained as well. If they drop too low, they can be fatal. So we don't think about all the things that we have circulating in our blood that has to be at a certain level. PTH, parathyroid hormone. Okay, so look at the thyroid gland. And you see the thyroid gland produces T3 and T4, which are just referred to as thyroid hormones. The T3 is triiodothyronine. You all should have it in your book. Make sure you all write the names of them down, because you may see them instead of T3 and T4. And T4 is thyroxine or tetra, something or other. Okay, so the thyroid gland, here, while talking about regulating calcium, the thyroid gland regulates calcium by secreting the hormone calcitonin under what conditions? When blood calcium is too high or too low? So then you'll see that on the test, a question just like that. So the thyroid gland, and see, I may mix them up too. I may say the parathyroid gland secretes calcitonin, true or false? When blood calcium levels are. So you have to remember which hormone is coming from which gland and what the effect is. Okay, y'all, a minute away from that, but you'll have it. So the thyroid gland secretes calcitonin under what conditions? When blood calcium is too low. When it's too low? I thought his job was to what?
Decrease blood. Yeah.
Decrease it. So
Oh yeah, when it's high.
So exactly. So that's how you have to start thinking about it. Think. Thyroid gland secretes calcitonin when blood calcium is too high. And what does it do? Lowers blood calcium. Okay? So if the thyroid gland produced calcitonin when your blood calcium was low, you may die. Okay, so it knows exactly when to and when not to secrete the hormone. All right, so it says the way calcitonin works, it stimulates the bone, right, in some kind of way, and it increases bone deposition. So you all remember that bones are calcium reservoirs. They store calcium. So whenever there's too much calcium in the blood, the calcitonin just sends it on to the bone. Okay.
Bone can't receive too much calcium.
No, not too much. Right.
So would that be stored in the red marrow? when they go into the bone, it be stored in the red marrow.
The outside of the bone, the white part of the bone. Yeah. So the hardness of the bone, what causes bone to be hard? What's in the matrix of bone? Tissue. The matrix of bone. Bone is what type of tissue? Going back too far? Is it epithelial, connective, muscular, nervous? One of them. So bone is a connective tissue. Tissues are made up of what? What are all tissues made of? Cells. Thank you. Thank you. Cells and? So if you have a tissue, you have a bunch of cells, but you also have that M word, matrix. So the matrix of bone is made of calcium phosphate. Calcium and phosphate, but primarily calcium. And that's what makes bone hard, remember? Another connective tissue is blood, which is not hard. And plasma is the matrix. So plasma is a liquid, which makes blood a liquid. Okay, so calcitonin, all we do is send that excess calcium that's in the blood onto the bone. And what about if the blood calcium level is too low? What does our body do? Very good. So y'all starting to get it. So the parathyroid glands secrete PTH, which increases blood calcium. And here you can kind of see the, and it's not red, so I'm not going to expect you to know the target organs, but that kind of gives you an idea of how. So how is PTH increasing blood calcium? So basically it's doing the same thing. It's stimulating the bone to what? To get rid of the calcium or send the calcium into the blood. Okay, so the calcium reservoir on the bone is going to, that calcium will be released back to the blood. Okay, and the kidneys, what do you think the kidneys are doing here then? What do kidneys do? Very important in helping to maintain. Right. Yeah. Exactly. So it filters the urine. Anything that's too high, it gets rid of. Anything that's too low, it keeps. So the PTH is telling the kidneys not to release calcium because we're getting too low. Okay.
Why is it that the kidneys don't? Like if somebody's blood pressure is too high to make their kidneys fall?
Because the kidneys function primarily on blood pressure. So if the blood pressure is off, the kidney's ability to filter is altered. It's very sensitive to changes in blood pressure. And that's a good question I kind of get to when we get to the later chapters. But yeah, usually if you see someone who has kidney failure, they also have or had for a long time hypertension or vice versa. So they kind of influence each other. Okay, so one of the reasons we need to take our medications if we're hypertensive. You know, I sometimes hear people say, I went to the doctor and they told me I have high blood pressure and I need to take something. I'm not taking nothing for blood pressure. One day you're going to wish you did. Yeah, you're going to wish you had. And I understand because a lot of times when you are first diagnosed, you can just diet and exercise and that'll fix it. But don't just say, I'm not going to take the medicine and you're not doing anything else to lower it because, like I said, it'll get to you eventually. All right, so that is, so can you all explain how the body controls blood glucose levels now? You think you could tell someone? If Miss Clayton asked you all, how does the body maintain or regulate blood glucose? Y'all just going to be looking at her like this? She tells me. Oh, yeah. Your students looking at me like, what are you talking about, lady? So you got it? All you have to do is remember what? Right, so the pancreas, that's easy. So the pancreas secretes insulin whenever your blood sugar is too high, and it lowers blood sugar. And There you go. Y'all get it. I know you have to go through it a few times. All right. Let me help you all on a few of these other hormones as far as their effects. Now, like I said, for most of the list, you see you see these in matching, where you have to match the hormone with the effects. So I told you all that TSH, instead of just memorizing that, you don't even have to write anything down. It stimulates the thyroid gland, right? Now, what I have up here is it stimulates the secretion of thyroid hormone, but it's probably best for you to write that it stimulates the thyroid gland to secrete thyroid hormone. So it's stimulating the thyroid gland, and we'll see down here the thyroid gland is going to secrete T3 and T4, which are thyroid hormones. And what about this one, this long one? Looks intimidating. Adrenocorticotropic hormone. Adrenocorticotropic. If you break it down, adreno probably has to do with what? Adrenaline or adrenal gland, right? And the adrenal gland has two parts. Where is the adrenal gland? Find a picture of it in your book.
Mm-hmm. It is.
Right, it's sitting right on top of the kidney, but I want you all to see it.
Yeah.
So the adrenal glands. So the name adrenal, what do you think that means? What does renal mean?
Kidneys.
Kidneys. Adrenal. So it's sitting right on top of the adrenal gland. Okay, so the adrenal gland has two parts. It has a cortex. Where do we see that word cortex before? In the brain. What part of the brain? The outside of the brain is called, the outside of the cerebrum is called the cerebral cortex. Well, the outer part of the adrenal gland is called the adrenal cortex. And the inner part is called the adrenal medulla. So those two parts of the adrenal gland secrete a different hormone. So the adrenal cortex, the adrenal medulla is pretty easy. Just think sympathetic division. So this gland, so now we're not talking about neurons. So neurons release norepinephrine, but so does the adrenal gland, the adrenal medulla. Okay? And the book also says the adrenal gland was once an adrenergic fiber, or had some effect on some part that it played in the sympathetic activity. So it secretes norepinephrine into the bloodstream. So the nervous system doesn't secrete neurotransmitters into the bloodstream, right? Notice the difference. So a neuron can only affect the next neuron, or what's right there next to it. Y'all with me? So neurons secrete a neurotransmitter, so they just have an effect on the neuron right next to it, or the effector, like the muscle or gland. But the adrenal medulla secretes norepinephrine, and it can have an effect on all the tissues, whichever tissues have receptors for norepinephrine. Okay, so the effects are fight or flight. So adrenocorticotropic hormone, adrenal cortex, you can tell that's what it's talking about, right? Adrenocortico, especially if you had medical terminology. All those O's. Adreno is the combining form for adrenal. Cortico is the combining form for cortex. So adrenocorticotropic, tropic, what that word means is that the hormone is going to have an effect on another gland. Okay, so wherever you see the word tropic, that means that hormone is going to affect another gland. Okay, so adrenocorticotropic hormone stimulates the adrenal cortex to what? Release their corticosteroids. And you don't need to know that part. So it's just know that it stimulates the adrenal cortex to secrete the those hormones, and there are several. Prolactin, you all told me the LACT, that helps you to remember. Think about milk, so mammary glands, and growth hormone, super easy, promotes tissue growth. Okay, and so you would expect for growth hormone to be important, for example, in a baby growing to be a 6 foot tall man, right? So the growth hormone is playing a role there. And let's see what else we can make sense of to help you all remember this. Oxytocin, that's kind of a weird word. I don't know if that one can help you remember too much. But just so in the posterior pituitary gland, you know it's going to secrete two hormones. One is oxytocin, which has a similar effect in some ways because of the lactation. It stimulates labor contraction as well as lactation. So you can, this is the hormone that stimulates labor contractions. So when a woman goes into labor, remember this was a positive feedback mechanism y'all may have learned about in 201. So how does positive feedback work? It enhances some effect. So most of what we need are negative feedback mechanisms so that when something goes out of range, it comes back. That's negative feedback, bringing it back to normal. Okay? So just like when insulin increases, negative feedback mechanisms cause it to come back down. With positive feedback, if you have an increase in something, positive feedback mechanisms make it keep happening. You know, it kind of elevates the effects instead of returning it to normal. So that's what happens here. When a person is in labor, they don't start having fewer and fewer contractions. And weaker contractions, they what? So once they start, they just get stronger and faster. Okay? And that's because oxytocin is going to stimulate the uterus to contract. Those contractions tell the posterior pituitary gland to secrete even more oxytocin. So that extra oxytocin will stimulate even more, and the signal goes back to the pituitary gland, and it's like a vicious cycle. It just keeps going and going until the fetus is born, and then it stops. Okay, and then ADH. ADH is anti-diuretic. Make sense of that word for me.
It stops.
Okay.
Urinating. Stuff in the urine.
Right. So diuretic. So first of all, what is a diuretic?
A water pill.
So a water pill is considered a diuretic. What do we mean by that?
It makes you urinate.
So it makes you urinate. Okay. And notice the hormones target the kidneys. So the hormone ADH is talking to the kidneys here. So as we said, a diuretic causes us to flush out or get rid of water. ADH tells the kidneys, oh, hold up, keep that water in the body. Why? So under what condition would you expect for ADH to tell the kidneys to stop getting rid of water?
When you're over your
Dehydration. Yeah. So dehydration. So under dehydration, if you're dehydrated.
because you don't want to.
Exactly. So the body needs to hold on to the water because dehydration, as we know, can be fatal as well. So this is just one mechanism the body has to hold on to the excess water. Okay? So it decreases urine output. And so uretic. While I'm here, in the future you're going to see other things with uretic on the end of it. So if uretic is on the end of it, that means it's getting rid of whatever that is. One of those is down here. Find the heart. ANP. Anybody find what that is?
Mm-hmm.
ANP.
Atrial natriuretic peptide.
Okay, so there's that uretic again. So atrial is atrial natriuretic peptide. It's a peptide hormone. All right, it looks like a whole lot, but if you know what those words mean, it's not so bad. So atrial has to do with the what? The atria of the heart, right? We have two atria, left and right. So it's called atrial because it comes from the atria. Okay? That's the part of the heart. And this hormone, atrial natriuretic. So the natri has to do with sodium. What's the symbol for sodium? Na. Okay, so natriuretic. So this hormone is going to cause the body to what?
Release salt.
Release sodium. Right? So it's going to tell the kidneys to get rid of excess sodium from the blood. And whenever sodium leaves the body, so does what?
Water.
What follows salt? What follows salt? Water. Yeah.
Outright? Water.
Yes.
Oh.
So if you get rid of sodium, so water follows salt. Always remember that.
Water follows salt.
Okay, so by getting rid of sodium, that's going to what? Lower the blood pressure because you're getting rid of water. Right? Does that make sense to you all? Very important concept to understand. How, and it should be so simple to you all. Maybe not right now, but it should be clear that if you lower the amount of blood you have, you're lowering what? Blood pressure. Pulling water out of blood is lowering the amount of blood, so that's lowering blood pressure. So remember, blood pressure is what?
The pressure against
Right, so what is exerting force against what? Blood is exerting force against the blood vessel wall.
Yes.
Okay? So if you don't have as much blood in there, there's what?
Less pressure.
Less force. Less force, less pressure. So by getting rid of salt, you're getting rid of water, which lowers blood pressure. So a person who has hypertension, they're told to limit their salt intake. Why? So salt, when you consume salt, where does it go? Into your digestive tract and then directly into your bloodstream. So whatever fluid, we have fluid compartments, body tissues have fluid. So if salt enters the blood, water is going to find its way into the blood as well. Increasing blood volume. So you have more blood, you have more pressure. Right. So that's why patients who are hypertensive are given a water pill to reduce the blood volume, which automatically reduces blood pressure. Yes.
So all hypertensive drugs have water.
Not all of them. Some of them work by just decreasing heart rate. Remember, there's several mechanisms for decreasing or increasing blood pressure. One is controlling the heart rate, right? Speeding up the heart increases pressure. Slowing down the heart decreases pressure. Releasing fluid, now you know, decreases pressure. Increasing body fluid increases pressure. Constricting blood vessels increases pressure, right? Because the blood is pushing harder if the space it's in is smaller. Then if you loosen it up, then blood kind of has space to wander without too much force. Okay, so we'll learn some of those other mechanisms. And this is the type of thing, once you all get to nursing school, it has to be automatic. Okay? Definitely before you graduate, it has to be automatic.
I can really understand this part, right? While we learning this part.
Good. Okay, so hopefully that helps. And then you have the pineal gland, Melatonin influences mood. This hormone makes us feel sleepy at night. So we have the pineal gland is secreting melatonin when it gets dark outside. It kind of can tell when we're in the presence of dark. And how people call the pineal gland the third eye because it responds to light and dark. So it releases melatonin, and during the day that melatonin converts to serotonin. And what do you all remember about serotonin? Affects mood. Remember, that's the feel-good neurotransmitter. So during the day, this helps us to feel good. And you'll hear about people who live in climates like Alaska. You hear that Alaska, some parts of the year, it's dark for 12 hours and only light for a few hours, maybe sometimes longer than that. So people up there during that time, they experience depression. It's called seasonal affective disorder, and they're just have big lights put in their house, so they're exposed to the light. And that keeps the melatonin converted to what? Serotonin, to make them feel better. The melatonin makes you sleepy and, like I said, grumpy, maybe even mean, mad sometimes. You ever see your kids, they get sleepy and they just get mean and irritated? Yeah.
That's a
It's
baby.
melatonin. Okay. And the thymus, you all saw the thymus produces thymopoietin. And it has an effect on the production of T cells. You micro students, y'all know about T cells. Stimulates the T lymphocytes. And we talked about thyroid. So you've heard of people who have thyroid problems. Usually they have gained weight or lost weight. And it depends on what the thyroid hormones are doing or not doing. So it increases metabolic rate. So if you have an increase in thyroid hormones, T3 and T4, then you expect the person to what? Be hungry, right? Because they have a high metabolic rate, they'll lose weight. So if the thyroid gland is overworked, then that's what you'll see. But usually it's the opposite. So if there's not enough T3 and T4, that will cause weight gain. Okay. Okay. And so those few things, basically, estrogen and progesterone, stimulate the female reproductive system to develop, regulates the menstrual cycle. Yeah, that's basically it, I think. The adrenal cortex, we mentioned aldosterone. So here's another hormone that affects blood pressure. And what it does is it causes the contraction of blood vessels to increase blood pressure. And that, of course, will be important also if a person has dehydration. Increasing the blood pressure helps there. And then this one, I didn't want to, well, we'll come back to this on Tuesday. Androgen and estrogen. And yeah, the placenta. So this is HCG. You all heard of this before? Human chorionic gonadotropin. So this is the hormone that if you're taking a pregnancy test, this is what you're testing for. This hormone is circulating if you're pregnant. Yeah.
Can we take that as a real
All right, so that's the intro. So Tuesday I'll probably spend a little bit of time going over the disorders of the endocrine system, and then we'll probably start 19 also on Tuesday. Yeah. Yep. All right.